Honorable Principal and respected teachers, I am Shaba Balam from AS and our project is a visual representation of an automatic sanitizer dispenser. As important as your hands are in doing work, they also equally contribute to the transmission of disease-causing pathogens. The fact that most work facilities such as toilets, bathrooms, and even restaurants are shared means that there are greater chances of disease transmission among the staffs, where personal hygiene is important. So, by having automatic sanitizer dispenser in these places will have benefits such as number 1, it improves hygiene as the level of transmission of pathogens will decline significantly. Number 2, unlike manually operated types that require direct contact every time a worker needs to use it, there is no contact with automated dispensers. This prevents or decreases the chances of pathogens passing from one staff worker to the another, and there will be a decline in infections among the staff, increasing its productivity and encouraging its usability. At last but not least, number 3, it is economical since the amount of sanitizer that is dispensed is the same every time. Unlike manually operated types where there is no uniformity which will increase revenues and profits in the long run. Now my team member Ridan Sharkar will explain its mechanisms.
Thank you, Shabab. Now the question arises, how does it actually work? Well, as you can see, this is the actual automatic sanitizer dispenser, and this is a see-through layout of the dispenser. In here, there are two compartments called the electric box and the proximity detector box. Inside the proximity detector box, we have a circuit joining the infrared LED, which emits near-infrared light of approximately 800 nanometers. When hands are placed underneath the proximity detector, the infrared light is reflected back by the hands, which is absorbed by the LDR. This acts as a trigger since resistance decreases. The circuit in the electric box is then turned on. This turns on the relay switch, which is connected to an external circuit containing the solenoid. Here you can see the solenoid. The solenoid gets magnetized and the soft iron is pulled, opening the slider, as you can see by the arrow. This allows the sanitizer to fall from here, from the dispenser. Then, after a time lapse of 3 seconds, the circuit is turned off by the timer 555 IC, and the soft iron is released, making the slider go back to its former position. The function of the timer might seem quite easy, but it is rather complicated. Now my team member, none other than Abra Shariar, will describe how the timer 555 IC actually works.
Thank you, Ridown. As you can see, these are the components of the timer 555 IC. There are 8 pins in total, and each of them carry out unique functions. In the beginning, the capacitor is discharged, so there is a 0 voltage potential at pin 6 and 7. Since the positive input at the comparator is 0 and negative input is 2/3 of the supply voltage, the output stays low and nothing happens. When the light on the LDR increases, resistance decreases and the voltage potential of the negative input of the first comparator is 0, while the positive input is 1/3 of the voltage supply. Therefore, the output is high. This output is connected to the set pin of the flip-flop. Its output turns on, which simultaneously activates the output of the IC in terms of the bipolar transistor. And now that pin 7 is no longer connected to the negative potential of the battery, the capacitor gets charged through the resistor. This is where the circuit is delaying to turn off. And when charging is finished, now the voltage at positive input of the second comparator is higher than negative input, thus its output is on. This resets the flip-flop and now the output of the IC is turned off and the transistor is on, which discharges the capacitor rapidly. And we are ready for another input. The higher the resistance, the larger the time delay. That's because the supply voltage taken by the capacitor to charge is lowered. The higher the capacity of the capacitor, the larger the time delay, and that's because it takes time to discharge a capacitor with higher farads. And we have used 11k ohm resistor and 250 microfarads capacitor. Therefore, the time delay will be 3 seconds, which is given by the formula T equals to 1.1 into capacitor 1 into resistance 1. This was in short a detailed demonstration of our project automatic sanitizer dispenser. Thank you.